thanks for being here in the morning of the second day. My name is Robert Mosolgo, and this talk is for you if you ever had a hack week and you did a GraphQL proof of concept, and then the CTO was like, this is great, but what about? So we're going to talk about a few of those things. Yeah, as mentioned, let's see. Why doesn't it go? Oh, there we go. I work for a startup called GitHub. Actually, I guess I'm a Microsoft employee now. I think that's our logo. I didn't run it by the brand guidelines, but I work on the API team at GitHub, so we maintain a lot of the plumbing type stuff for the REST API and GraphQL API. So helping the feature developers get their APIs out the door and do it in a way that's fast enough and secure enough. And I've been there about 2.5 years. Besides that, I maintain an open source project called GraphQL Ruby. That was introduced a little bit yesterday. You can see that I starred my own repository to try to, make it look cool. So you can do that too if you want to make it look cool. And besides that, I live in Charlottesville, Virginia. That, I guess, was famous a couple of years ago for like a Nazi riot thing. Sorry if you were in town for that. I was not a very warm welcome to the visitors. But this is the mountains near my house. I'm more into that. And my wife and I are raising 3 daughters. One of them is in the picture twice. You can figure that out. And this is just when the street cleaner came through our neighborhood, which was that was a big event. So, and besides software, I make cheese at home, which is a big mess. But I think I was saying to someone before that sometimes computer people need some danger and excitement in their lives, and that's where The thing that I love about cheese really is that it's like a tour de force of all the best parts of traditional food preservation. So this is actually an action shot. I've sprinkled a little bit of bacteria in there, and they're growing and digesting the lactose milk sugar and producing lactic acid that prevents other bacteria from growing, which is a good start if you're trying to put milk on a shelf for months. The next step is to introduce some enzymes that break down the protein, and they cause them to undissolve, precipitate from the milk, and collapse down on each other. The book calls it a protein matrix. I like to call it a protein jail that traps the big fat globules inside while the water can flow out freely. So I read a funny description of cheese making that said, you simply remove the water from the milk, and that's how you do it. That's my press. It's kind of a janky squeezing the water out. And the last part is aging. This is my mini fridge cheese cave where you intentionally grow mold on things. There's some brie that's coming along. I handled it a little too rough. You can see it's got some spots, but yeah, this is like the fireworks show of cheese making where everything goes in looking like kind of a white blob, but depending on slight differences in salt and moisture, fat content, acidity, they all become really different. Quick shout out to Shopify. All my favorite home cheese making supply retailers are apparently based on Shopify, so I recognize that checkout flow anywhere. Yeah. I have 2 favorite home cheese making supply retailers, and they both use Shopify. Enough about cheese. I'm also here to talk about GraphQL, but if you don't like GraphQL, you can talk to me about cheese later, too. And if you don't like cheese, I'd be interested to hear more about that, too. Or if you choose not to eat it. All right, a quick introduction to GraphQL. We did have one yesterday, but if it's new for you or to make sure we're all on the same page, I'm just going to introduce the concept from a high level. So GraphQL's website calls it a query language for your API. And so there's really 2 things to take away from there. One is that it's an API. So if you have a web application and you want your web application to talk with the outside world, you need some kind of interface. Maybe it's a user interface. Maybe it's an interface for other software systems. And it's a query language. So the things that come and go are written in a query language like SQL. That SQL is also a query language. And so here's a little example of that. You can see we've got an HTTP API there with a path. And here's that structured query string. Something that Jamin and Morgan mentioned yesterday is that the cool thing about GraphQL, one of the things, is that you can ask for whatever you want as long as the API it's something that the API supports. So here we're asking for a certain repository by name, and then some related objects, the first 5 issues that are open, and then for each issue, some information about it. And what the endpoint will return is a JSON response that's structured in the same way the query was. So there's the repository and the issues, and it looks like there are only 4 open issues, and then each one has the attributes that we requested. On the Ruby side, we saw a little example of this yesterday. There's a schema, which is a bunch of classes all connected to each other, and one of them might look like this. This represents a repository. Sometimes these objects map to your active record models, but if you happen to work on like a 12-year-old app and you don't want to share your database structure with the world, you can model this according to your application's concepts instead of according to the implementation in the database, and that's one of the things that appeals to me about it. And you can see that for these relationships from one kind of object to another, they can be implemented with methods like that. So this is very cool, but there are a lot of cool things in programming. Why would you bother doing this? Here are a few reasons that we use GraphQL at GitHub. One is that we have a lot of clients who they want to be empowered to build stuff. They know what they want to build, and they want flexible and easy to use access to that data. So an example is a CI integrator who needs to be running the same kind of transactions all the time. They can either do that in 5 or 6 REST endpoints or in one big GraphQL query. Another advantage to GraphQL for us is that I mentioned there's a schema on the server, and there are a bunch of rules that they're part of the GraphQL spec about how that schema can change over time and how it can't change over time. And so it gives us a really clear framework for understanding how we can change our APIs. And it gives our clients some understanding of what we are and aren't going to do. And finally, an interesting advantage from our standpoint is that a lot of our REST APIs, they return a representation of an object, whatever we decided a representation was 6 years ago. And so sometimes there's a field on a repository, for example, maybe it's really expensive to calculate. We have to call out to the Git file system and merge it with some stuff from the database and do some calculations, but we don't know if anyone's really using it. And so these maybe unused fields, they waste a lot of time on our server, they waste our client's time, and they don't actually want it. But maybe they do, we don't know. So with GraphQL, a client can request just what they need, and they don't have to wait for anything else. Here are some reasons not to use GraphQL as you're considering it. One is that it introduces some overhead because it's a complicated system that's made to run dynamic queries. And so if you and your clients know exactly who needs what, then it might not be a good fit because you would pay tax for flexibility that you don't need. Another one is that if you think of rendering a Rails view, for example, you might run all the database queries at the top of the controller and then render the view. And you know exactly what queries you have to run because you know what the view code is. With the GraphQL query, the incoming queries, it might be anything. And so it's much harder to implement in an efficient way. We're going to talk more about that. The other one is that not everybody knows how to use GraphQL. The tooling is not as good as 15-year-old REST tooling. And depending on your industry, people might not want to learn it, depending on who your clients are. So with that in mind, I wanted to share a few things that our team has been working on at GitHub over the last year or so in terms of GraphQL. So the first one is authorization. I mentioned before comparing the GraphQL paradigm to REST endpoints or Rails controllers and views. And one of the great things about a REST endpoint is that you know exactly what you're going to return. And so authorizing an endpoint is pretty straightforward. Who is the current user? What kind of thing are we expecting to return? Is it okay to do that? With a GraphQL query, it's much more complicated because you don't always know what things you're going to return. So here's an example query. Maybe I want to know what DHH has been up to lately. When that comes to the server, how do I know whether I should run it or not? And if I do run it, how do I know whether I've returned something that I shouldn't have? For example, the first 10 issues, maybe they're all Ruby on Rails issues and it's public data. Maybe they're all Basecamp issues and it's company secrets that I'm not allowed to know about. Here's how we approach that problem I showed earlier the idea of a GraphQL object, and there's really two parts of the GraphQL runtime. One is objects like that, and it's a thing that has some fields. And the other one is scalars, and those are kind of like leaf fields. So title is an example of a scalar. It's a string. It doesn't have any properties that you can ask about. It's the property of something else. And the other one is objects. That's a thing with properties. For example, a user is an object, and you can ask the fields of a user. An issue is an object. A repository is an object. So when I started at GitHub, they had actually found a pretty good pattern for authorizing GraphQL already. What they did is they said, anytime that the query is running and we encounter a new object, let's run an authorization check on that object. And so at runtime, the way that would look is the first thing we do is load a user from the database and go call some kind of authorization hook. Hey, can the current viewer see this? And if they can, then we go down to the next one and we load the list of issues. And for the first issue on the list, can the viewer see this? Yes, they can. For the next one, here's a repository. Can the viewer see this? Yes. Great. Next issue on the list. Can the viewer see this? Next repository. Can the viewer see this? No. OK, that means some of the database filtering in the implementation of the API was wrong, and some object that should have been kept back was actually almost returned to the user. And so what do we do in that case? There's basically two, maybe three options. The third option is just to return it anyways. Don't do that. The first option is, if an object is not allowed, replace it with nil. And there are some times that we do that, but in general, we don't do it because leaving a nil in the response actually shows that something is there. And if you've ever tried to like visit a top secret project on GitHub or something that your teammate hadn't given you permissions to yet, it says 404 because we don't want to disclose what our customers are working on. And so it's important. Imagine we gave a list of 4 repositories, but one of them was nil. You could sort that list a bunch of different ways. For example, when was it created? Sort them by name, sort them by number of stars, sort it by language, and you could start to learn things about this mysterious nil. I feel like that's how we learn about black holes. It's just how they influence the universe around them or whatever. So what we do instead, if something slips through, is we crash the query entirely. This puts something on our bug tracker. We look through the stack trace to figure out, OK, where in the API did we return the thing that failed the check? And hopefully it's somebody else's job to go fix that. Implementation-wise, it looks basically like this. Here's another one of those GraphQL object classes. In the previous example, we saw the field definitions, and I've left those out here. Instead, what you see is this class method called authorized, and it receives the application object, like in this case, it would be an instance of the issue model, and the GraphQL context, which is a thing that's always going in GraphQL. And anytime before we're going to resolve fields on one of these objects, we go through this hook. And so the advantage there is that there are lots of different ways to get an issue from the API. You could load it by ID. You could look for the issues that DHH has authored recently. You could search issues. Any other ways? I think maybe that's it. And no matter how you get there, it will always go through here. And so that's a big advantage to this object level authorization hook. So that's something built into GraphQL Ruby. If you download it and start running those class methods, that'll work for you. The kind of things we do in that method in GitHub, one is that we check OAuth scopes. So when we get an API request, it's been authorized to look at certain things, and all the other things it's not authorized to look at. Some of that checking we're able to do ahead of time because the query is structured according to the schema. But some of it we have to do at runtime. For example, we have a public repo scope and a private repo scope. And from a static query, we don't know whether the first 5 repositories are going to be public or private. And so that's one of the things that we check at runtime. There's also something called GitHub Apps, which is really similar in that you can give granular permissions. And then we have an explicit table of granted permissions. We check those. And finally, there's application logic that determines should this user see this thing. For example, if I invite you to collaborate on one of my top secret projects, if you accept my invitation, then you get a granted permission. If you haven't accepted it yet, There's an open invitation, but you don't have the grant. So it ends up getting a little bit complicated, but you can do a lot of stuff inside that method. So if you're interested in that, you'll find some documentation online, and that's a conceptual and then some how-to also. And that's stuff that we took out of GitHub because it worked pretty well. Another area that we've been working a lot, and this is also something that Jamin mentioned yesterday, was how do we run effective or efficient database queries in this paradigm? With a Rails view, you might look at the ERB, figure out what kind of objects you need, and then you can do things like includes and joins. And is there anything to do except includes and joins? And there you have it. But with a GraphQL query, it's very hard to know ahead of time what kind of data you're going to need. So the technique that we apply here instead is called batching. And here's basically how that works. It made me think of batches of pancakes, which is why I put a pancake. Let's say that you are, have you ever heard of those companies that say that they have some AI service and then there's a scandal and they're like, nope, it was just people in an office answering questions. Let's say that we implement our GraphQL API by me coming to your desk and like putting the query on your table and saying, would you please write up the response to this by 2 p.m. Friday? The client is waiting for it. And I give you this one. What we're going to do here is select a user named DHH and then ask for some things about that user, and then a user called skmets and some more things, and then same thing for mats. The easiest implementation here, and if you have until 2 p.m. on Friday, would be to make first query for the first one and then resolve the fields. Then query for the second one and resolve some fields. And then for the third one. And what you end up here is 3 round trips to the database that incurs a lot of transaction costs as you go from Ruby to the database and back and forth and back and forth. So if you were in a hurry, maybe I come to your desk, this needs to be done yesterday. This is not a good GraphQL implementation. There's a more efficient way that you could write this as a clever human by loading all 3 at once. That gives you only 1 round trip to the database and saves a lot of the transaction overhead. This is an easy enough example because you know exactly which users you're going to load. It gets a little trickier in a case like this. Maybe I want to see what's up on the Ruby compiler rack. And so what I've loaded is the first 10 pull requests and the author's name, who's been working on it lately. If I plop this down on your desk and I say, which authors is that going to load? The only way you can know is to run the query part way, see what the first 10 pull requests are. And then you'll know what authors to load. So this is where batching comes in as a dynamic technique for loading data. Here's an example object class with an author field. This is the same one we were looking at. And you can imagine an implementation that instead of what you see here, it just says object.author. And that dispatches a call to the database to load a single object by ID. That would give you a textbook n+1, because each time you encounter the author, it's going to load 1 object, and then again and again. In this case, we're doing something very weird. Instead, we're grabbing the foreign key, and we're returning a promise using something called a loader, which we'll get to. And what this represents is a request for data when it's handy for GraphQL to give us that data. We say what we'd like is a user with this user ID. And we just return that request when it's handy. Please run that. And from GraphQL's standpoint, you end up with a workflow like this. First, it runs as much as it can, just resolving fields eagerly and gathering up these requests for data later. Then it reaches the end of everything it can do eagerly, but it has this bag of requests, and it says, all right, let's see. Who asked for a user? OK, user ID 1, user ID 10, user ID 21. And now let's run all those as a batch. So that's where you could do this select where ID in. And you may have several different kinds of batches, users and pull requests, and maybe calls to an external, like a REST API or a search engine. And we do some of those. Now we've got more data to work on, and so GraphQL runs some more, gathering up more of these delayed requests for data, and then it runs through those. And then it goes back to running, back and forth until it reaches the end. Implementation-wise, a loader looks something like this. It has a kind of unit of batching, which in our example before was the user class. Here's like a model class. And then as it gathers up the kind of values that it's going to load, finally it's dispatched with all the different IDs to load. And here's where you, instead of an n+1, run a single query. So we use a library called GraphQL Batch from Shopify, who actually when Facebook announced GraphQL shortly after, they had a JavaScript implementation, and there are a few Ruby libraries that do the same thing. And the advantage here is that the loaders that I've given an example of that happen to be active record oriented, but we do the same thing with Git RPC file system calls, for example. Another thing is, let's say lots of fields need the same user. For example, those first 10 pull requests were all authored by the same person. We deduplicate those keys before we dispatch the batch. Finally, GraphQL Batch keeps an identity cache. So if we request user with the ID 10 and we've already requested that, it returns the same object right away. At GitHub scale, the advantage there is that rather than maybe hitting the database, maybe hitting Rails's SQL cache, in either of those cases, it's going to reinitialize the user object with the same ID. And we have a few God objects in the source code that take a long time to initialize. So it's nice to reuse instances when we can. So we've been using GraphQL Batch for a while, but we're starting to realize if we could integrate this with the GraphQL runtime, we could do even better. And here are a few things that we're looking into. One is trying to improve the speed, reduce the latency for clients. And a way that we could do that is by introducing parallelism. There's a proof of concept from a guy who works at Strava, who it's one of these open source contributors that never heard of this person before, but opened a pull request to refactor the library internals that's way better than how it was, and then don't hear from them for 6 months, and then another amazing thing. This is one of those. And the basic idea is like this. You might have heard that Ruby can't run in parallel, and that's right. It has a global interpreter lock that says only one line of Ruby code. Ruby can only be doing one thing at a time. Even if you have several threads, the interpreter will run one thread for a while and then the other and go back to the first one and then another. The exception is that when the Ruby runtime is waiting for an external service, for example, a query to the database and the database is working, or a prompt for user input, or a call to a REST API, Ruby does know how to wait on multiple things at once. And so I/O, the general word for those external service calls, that can happen in parallel. So if we had 3 different kind of batch loads for different kinds of objects, the current implementation is to first run the first one and just wait, and then run the second one and wait again, and then run the third one and wait again. And so we end up with long wait periods there, waiting for the search engine to respond, waiting for the file server to respond. And we could probably do a little better if we could start the first I/O call and just forget about it, start the second I/O call and forget about it, start the third one and forget about it, and then wait for them all to be done. That would be a nice way of speeding things up a little bit without too much complication. So in practice, I'm sharing what I have in mind. There's an open pull request that's not closed yet. And so if you know more than me about this, I would like to hear your opinion afterwards. In practice, it might look like this. Here's a similar loader. For a certain repository, we're going to load a bunch of commit information according to the SHAs of that commit. And if we're going to do that in parallel, we could probably use this concurrent Ruby library that's rock solid. It ships with Rails since Rails 5 or something. And it maintains an internal thread pool, something like 5 threads, that it will queue up work and then distribute them among that thread pool. And you can just wrap some work in a block that it will dispatch in that thread pool. So the catch here is that your application has to be thread safe, because all of a sudden work is going to be happening in environments where thread.current is different. And I think that will be a tough climb for us. But some people design their applications thread safe from the beginning, so that's awesome. Another thing that we could improve if if we built this into the runtime, would be to stop making people solve the same problem over and over again. For example, in Jamin's talk yesterday, when he and Morgan gave the example of if we asked for the posts, the author of each post, and they said, oh, if you're careful, you can make sure you don't run an n+1. This is what you have to do for that. And anybody who runs GraphQL Ruby in production probably does that. Or if maybe they don't need to yet, good for them. They'll have to eventually. But this is something that we could solve, maybe like that, and maybe in even less code. And I would love to just make that default case a lot easier. So I'm trying to build in batch loading. The folks from Shopify are interested in the same thing, and like a lot of GraphQL stuff, they have shared their different shortcuts and techniques, so I think we can work on something that's going to be really, really solid. So if you're interested in this, there's a pull request that I'd love your comments. If you know more about concurrent Ruby than me, then please leave a comment. But I'm looking forward to working on that some more. The last thing that I wanted to talk about, this one is really out there, is some work that our team has been doing recently about keeping an eye on our API's performance. And again, this is something that in a REST API is pretty straightforward. You record how long endpoints take, and then you push them to Datadog, and you look at your endpoint performance in Datadog. But with GraphQL, it gets pretty tricky because there's only the one endpoint /GraphQL, and there's a tremendous variation in the size of the query. For example, we do have a Datadog dashboard for GraphQL, and it looks like this. So 50th percentile is this blue line, 75th percentile is that purple line, and up here is the 95th percentile. If this was anything else, you would know that something was terribly wrong, because there's like, I don't know, 20, a function of 20 or something between there. But with GraphQL, I actually don't think there's anything wrong. The reality is that some GraphQL queries, and the vast majority apparently, are really easy for the server to fulfill and respond to. Others, which are legitimate GraphQL queries, they're just complicated and asking for a lot of data, take a long time to respond to. So how do we know, with so much variation, how do we know that things are running smoothly, or that I haven't introduced a regression or a degradation? Or if I release an improvement, how will I see that? I haven't had that problem yet. There's a funny technique that I've used for a couple of years that finally inspired a solution. So something you may not know is that part of the way that GitHub adopted GraphQL was along with the Rails view layer. So several views in GitHub actually run a GraphQL query to get their data and then render the view. One of those views is the pull request show. Has anyone in here ever looked at a pull request on GitHub? It's just a joke. And so I use that kind of as a canary. Whenever our team releases some change to how GraphQL works, we use views like that to make sure that things are running smoothly, because that's a pretty important view on github.com. And the cool thing about that is we know the query is pretty stable. There's still a big difference between 50th and I think that's 95th, but it's like 10, no, less than 10 times, 6 times instead of 20. And we can use that as a benchmark or like a canary in the coal mine to make sure things are running smoothly. But the problem is I don't know what our API clients are doing. I know what the pull request show page needs. I have a good way of recording just that query because we record the page view. But what about our clients? And that's when it hit me. Maybe we can figure out what our clients are doing. The reality is, if you've ever worked on a GraphQL client before, a lot of the query strings are hard-coded in the application code. So, for example, if you are working on the deploy integration with Heroku, you probably have a hard-coded query string with some variables in it. And depending on who's doing the deploy and whose repository needs updating, you send the same query string with some new variable values. And so what that looks like for us is that they send us a GraphQL query, and we give them the response. But in the background, we enqueue a job and later parse that query and do some processing on it. We keep track of who's using which GraphQL fields so that if we do have to break something, we know who to talk to. And we do sunset things sometimes, and we like to make sure that everyone's taken care of. So we process the query here, and then we write it to the data warehouse. It's not a very big data warehouse. But so we have this workflow for processing queries, and I thought maybe we could take the same mindset from these views, but apply it to our client's queries. And so what we end up with in this data warehouse is the query string that the client ran with a lot of values scrubbed out of it. We know how long the query took to run. We know who ran it or who it was run on behalf of, and then what kind of integration or app or personal access token or whatever. And this gives us a pretty good signature of the kind of transaction that they're trying to run. And we can track that over time. For example, like a big company whose compliance workflow runs over GraphQL, we can watch that query using a signature like this one, maybe not with the user there, and see how it performs over time. So I've started to look at that, and here's kind of what the charts look like. So here's a query that's run about 150 times a day for the last 2 weeks. There's the data lag. I don't think they just gave up on the API. And you can see the different components of the timing here. So CPU is basically how long were we running Ruby code, and then our two biggest external services are the database and Git file system. And if you see, things are pretty stable there for 2 weeks until a couple of days ago. Suddenly, there was never any Git RPC time, and now there is. There was the MySQL time was pretty stable. There's spikes there, but especially at the 99th percentile, you can imagine there's a deploy going on or some resource contention. It's not terrible. But even the P50, the average time, has increased in the last couple of days. And you see a similar spike in CPU in the last couple of days. Now there's an interesting thing is that more database time will actually create more CPU time, because for example, if there are more database queries, then Ruby has to process that and turn it into objects. So something has changed in the last couple days. The question is that a problem? It kind of looks like yes. So yesterday someone mentioned the word alarm fatigue, which I had never heard that word, but my heart has been longing for it all this time. Is that really a problem? This is what I've been waiting for. Because it may actually not be. I showed you an example query earlier that said, for this repository, show me the first 10 issues. And for each issue, how about some information about it? Now, in fact, for the GitHub API, you can make a much bigger query than that. You can say, show me the first 100 repositories. And for each repository, show me the first 100 issues. And for each issue, show me the first 100 labels on that issue. That's the time it takes to run that query is very dependent on how many repositories are there. If there's only one, it's going to run quickly. If there's actually 100, and each one has 100 issues, and each issue has 100 labels, suddenly the same query string will take longer to run because it's actually processing more data. And so one thing that's missing from this analysis, and I guess I should work on that on Monday, is accounting for the size of the response. Because I think you could use how much data was returned as a way to measure, is this taking longer because there's actually more data to work on? So that's something that I'm still working on. And here's a couple other things we keep track of for the same query, which is the number of operations. And you can see that the number of queries has increased. So that could be because there's more data, we have more associations to fetch. It could be because we've introduced a regression and we're making wasted queries where we don't need to make them. It could be because we fixed a bug. We used to not make enough queries and now we do. But I'll have to look into that. So since the signature of this includes the GraphQL query, I could look back and start trying to guess, what parts of the schema does this touch? Can I make sense of this change? But I think the key bit is the size of the response. So I'm still a little bit stuck on this, but I share it with this room of smart, interested, and interesting people in the hopes that you will open an issue on GraphQL Ruby and tell me how you figured out how to solve this problem. Or maybe I'll open an issue with something that works. But if you have anything in mind, please do talk to me after the talk. So that's basically it. So thank you for listening, and I hope you enjoyed it and your gears are turning. So thank you very much.